Hello YouTube, this is Latrell Jackson here from Harvard University with our science experiment. Today we'll be doing, our question is, what liquid will make the pepper repel the fastest? So we are using, these are your basic ingredients that you'll need. You need olive oil, water, milk, black pepper, and hand soap. And you will also need plates, but it depends what kind of, you can use glass plates, paper plates, or any type of plates, but you have to have enough for how many times you are conducting the experiment with each liquid. So all of these are household materials. They should be household materials for you. So first, I'm going to tell you my hypothesis. I think that the water will have the most effect because it is natural and doesn't contain any chemical. So water, honestly, if you look on here in its ingredients, it really doesn't have like a lot of ingredients, like purified water, calcium chloride, and that's really it. So it doesn't have a lot of ingredients. So make sure that you just don't overfill it. Just pour it on here until it's filled, because you're going to need it to go to the corners, because that's how you're going to see once the first little pebble hit the corner, then that's when you're going to stop our timer. You are going to need a timer. It doesn't matter, a phone, a timer. You'll need something to time with. And if you are using this for a science experiment, make sure you have your paper ready. So you're going to be careful with the pepper. If you touch the pepper, make sure you don't touch your eye so you don't burn yourself. First, I'm going to do the milk first. Let's see the milk's reaction. So make sure that you get your timer ready. So, ready? You just pour it in the middle. It's going to spray a little bit. So you can see right there. It's going to start spreading. You don't have to wait till it stops spreading. Make sure. Now, look. I'm going to pour it, not a lot, on your finger. Make sure you have a napkin, paper towel ready. And we're going to bow. You can stop. You didn't touch your side yet. I'm gonna wait till it touches the side. Till the first pebble touches the side. Okay, there we go. 25.34 seconds for that. This is our third time conducting this experiment. The other time we got 10.46 seconds and 4.00 seconds. So this time we have 25.34 seconds. So now we are going to move on to our water. This was my hypothesis. What I picked was going to be the fast because it was natural. See, that's automatically going to spread out, but it really doesn't matter with that because it's all kind of going to come back up to the middle, and it's going to, you'll see once we start it, you will see. We're going to reset our timer. Oops, make sure you have your timer ready. Oops, I already have that. I'm sorry. Make sure you put it on your hand. So, ready, go. Stop. 2.36 seconds. That was fast. Hopefully the olive oil can beat the water. If the olive oil doesn't beat the water, then my hypothesis will be correct. So 2.36 seconds. Run the time in. So now we're gonna move on to our next liquid. Our next liquid is olive oil. You can use cooking olive oil, any olive oil. Just make sure that it's like a kind of oil that's like this. I wanted to try different textures. I know milk isn't exactly the same texture as water or olive oil, but they're all different textures. Wanted to try something with different texture. Okay, so now we're gonna make sure you don't pour a lot, like I tell you, for all of them. See this one, that's how you could tell. I don't think this one's gonna do it because see, that's not moving at all. If you can see on there, that's not moving. So see, ready, we're gonna start our timer. Oh, it's moving, but it's not moving fast at all. You can see that's barely moving. Moving very slow compared to the water in the milk. See, and you see that the pepper cannot dissolve into the water. Now I'm going to tell you that pepper is hydrophobic. Hydrophobic is hydro means hold up. I'm sorry. Yeah. Hydro means water and phobic means phobic. So it cannot, so phobic means that it cannot be like, the pepper cannot dissolve into the water. So that kind of looked like it stopped. That's why you see on all of these, the pepper is not sinking under. See, yeah, that stopped. So 45.46. You have that for the oil. 0.45.64 seconds. So after all, my hypothesis was correct, but my reasoning was wrong. So the reason that my reasoning was wrong was because I said that water was natural, water is natural, and I said that water was natural, and that's why the pepper went back. Water has a special molecule that when the soap comes to the pepper, it kind of like creates a wave, and because water is natural, it makes the wave easier to form, but my reasoning was still wrong because it's the molecule that makes it go faster. It wasn't because it's natural. So after all, our milk, we conducted our experiment 3 times for each liquid. Our milk was, at the first time we conducted it, 10.46 seconds. The second time for milk, exactly 4 seconds. The third time that we just showed you guys is 25.34 seconds. So that was for the milk. This did a little bit fast, but now we're gonna go to our oil. Our oil, we have for our first conduction that we did 58.14 seconds, 59.24 seconds, and 45.64 seconds. And olive oil was the slowest out of all of them that we can see. It almost went up to a full minute. So our H2O, or our water, what we have, the first conduction was 2.15 seconds. Our second was 2.23 seconds, and our third was 2.36 seconds. I honestly do not know if the temperature of any of the liquids affect the pepper or in it going back, but if you guys know that, make sure that you comment and tell me that. So I'm going to tell you why some of these some facts and some background data on this. So soap breaks up into the oil. Soap breaks up the oil into smaller drops, which can mix with the water. It works because soap is made up of molecules with 2 different ends. One end of the soap loves water. They're hydraulic. The other end of the soap molecules hate water. They are high. What does that say? Hydro. Oh, I don't know what that says. That's a difficult word. We have pepper can't dissolve in water. As the soap moves into the water and the surface tension changes, the pepper no longer floats on top. But the water molecules still want to keep the surface tension going, so they pull away from the soap and carry the water with them. And that's what I was saying with the water, why it was easier to pull back, because the water doesn't have like any sticky substances, and with the water is all natural, so there's nothing pulling it back besides the water, and the water is coming back with the soap and the pepper. It looks like the soap is standing in the middle, but the soap is not standing in the middle. That's like the color dye. The soap is, if you can look in here, if you can look and see inside the soap, you see like those little dots? That's the soap. The rest of that is like a gel that they make. So, hydrophobic, that was the name of the word. So the other end of soap molecules hate water. They are hydrophobic. Hydrophilic is the other one. So I'm going to read it over again. Soap breaks up the oil into smaller drops, which can mix with the water. It works because soap is made up of molecules with two different ends. On the end of the soap, molecules love water. They are hydrophilic. The other end of soap molecules hate water. They are hydrophobic. So hydrophobic and hydrophilic, they are opposites of each other. So that's why pepper is hydrophobic, because it can't sink underwater, and the pepper doesn't want to stay within the center, so the pepper pulls back with the soap. So thank you for watching. I hope you learned something off this video, and have a nice day.